In this video, we're going to look at example 1 from section 3.2, where we're going to add and subtract polynomials. So we're asked, how do you add or subtract polynomials? And really, all we need to point out here, all I want to point out here, is that we're looking for like terms to combine these. Right? And like terms means that they have the same base and the same exponent. So if you look at this 6x cubed here, we're looking for anything else with a base of x and an exponent of 3. In this case, nothing else within that set of parentheses has that, but this 2x cubed is a like term. Right now, I'm just going to label them first, and then we'll worry about removing the parentheses. So I'm going to go piece by piece. Next, I'll look at the 4x. Nothing else has a base of x and an exponent of 1. All right, I see bases of x with 2 as an exponent, but nothing just x. X squared going across, that would match up with minus x squared. And then finally, this constant, minus 7, and plus 3 would be like terms. So it's important to remember when you're adding or subtracting, you are looking for the same base and the same exponent. So I'm going to rewrite these without the parentheses. Since it's an addition problem, the parentheses in the second group don't change, or I'm sorry, since it's addition, we're not going to change anything about the numbers that are in the parentheses. We're just going to bring their signs with them. So the 2x cubed stays positive, the negative 8x squared will stay negative. I don't know what happened there. Let's erase that. And then the plus 3 will just come right down. So I'm going to quickly just highlight those again. I'm just going to match them up. So we can just follow along here. All right, now the next part of this, I'm going to group them together. So I'm going to put the 6x cubed plus 2x cubed together. You don't always need to do this exactly this way, but I just want to put them all together. Then I'm going to add, and I'm going to put them in decreasing order of their degree. So next we would have x squared. Be very careful with your signs here. Minus 8x squared. What do we got here? We just have 4x. All right, there's no other like term. And then we have a negative 7 plus 3. I wouldn't always recommend writing this step this way. I'm just doing this to show how I'm pairing them up or let's say grouping them up. Okay, so do be careful with your signs. So 6x cubed plus 2x cubed. Now that we can start combining the like terms, finally that we're getting to this part, we're only going to add up the leading coefficients. So it'll be 8x cubed. When you're adding or subtracting, you don't change the degree, right? The power, the exponent, that all stays the same. Next, we have 1x squared minus 8x squared. So that's going to be a negative 7x squared. The 4x, it's just 4x. We're not going to change anything about that. And then we have negative 7 plus 3. That'll be a negative 4. So we are going to subtract 4 here. All right, and that's it. I'm not going to highlight those last ones, but the idea here is that you are combining your like terms. I'm going to rewrite this real quickly in a shortened version. So what you'll probably see or probably get used to is, since you know it's addition, once you get good at this, you would do 6x cubed plus 2x cubed plus x squared minus 8x squared plus 4x minus 7 plus 3. So you'll see it a little bit more where you're writing those terms out. When we get to the subtraction, you will want to be careful with that. So this would be 8x cubed minus 7x squared plus 4x minus 4. And that's the same solution. It's the same answer. We're just looking to, again, combine your like terms. It does help to be very careful and cautious with these. The process itself is pretty easy. Really, the only mistakes are ever made are just going through the problems too quickly. All right, let's look at part B. Part B is the same idea. What they're doing here, though, is that we have two variables, and this is a subtraction problem, so we definitely have to be careful with that. All right, so here, again, I'm going to pair them up. 3x squared y squared. I need, again, the same base and the same exponent, but they both have to be x squared y squared. So this second term right here, although it has a y squared, x is to the first power, so that doesn't match up. All right, so this 2x squared y squared would be its partner or its pair. Next, I have 2xy squared. I have a 3xy squared over here, plus 6x squared, and minus 2x squared. So do be careful with that. Make sure that all of the bases and all of the exponents match up. So 3x squared y squared plus 2x y squared plus 6x squared. Now, since it's subtraction, that subtraction sign needs to be distributed to everything. So it's going to be minus 2x squared y squared minus 3xy squared, and then plus 2x squared. Again, I'm going to highlight the ones that match up. Just helps me keep track of them. Obviously, we don't always have that convenience for writing this by hand with pen or pencil, unless you have a lot of highlighters. So I'm going to combine them. 3x squared y squared minus 2, that's going to be 1x squared y squared. Again, when you're adding or subtracting, we don't change the base or the power. We're only combining the leading coefficients. Positive 2 minus 3, so that would be negative 1xy squared. And then 6x squared plus 2x squared would be a positive 8x squared. So once again, please do not change the exponents when you're adding or subtracting. And this would be your solution. So you definitely want to show work. I wouldn't go right from here to here. There's just way too much room for error. What I would recommend doing is removing your parentheses, writing the terms out, and then labeling them somehow. Let's say you don't have the options for all these colors. I would recommend maybe, let's say I had this written out. One of the options you can use, obviously instead of highlighters, you're not going to be carrying highlighters around with you everywhere. You can do something like underlining the ones that are like terms, and then use a different form of underlining. So maybe like a squiggly line, and then maybe something like a dotted line here. And that might help you organize them, whatever works for you. But you're only combining the leading coefficients, and to combine like terms, you need like base and like exponent. It has to be both.